And then later on, we will move to discuss on computer hardware. So as it is, when I say software, I mean the intangible parts of a computer. When we talk about the hardware, we talk about the tangible parts of a computer, what you can touch. So as software is of you see, I told you Glory Kature is not in class, and you can see how she's interfering us. That's why I insist put on your videos. You see, so will we assist that one? Yes. Can someone help us or we want to continue? Godwin, what can we do with that? Is this really a class, even if it is you? Can we leave her to continue? Yes. What do we do about this, Godwin? Can you advise us on this? Yes. Yes. Neon, can you advise us? What can we really do on this? The two people, Aniga and Gloria, and I told you, these people are not in class, as you can see. So I'll just have to remove these people. I don't mind this. I'll have to remove this. Yes. Now we can continue. Sorry for the interference. So I was talking about software, and I said software are a set of programs which directs computers to achieve specific, certain specific tasks. Then when we talk about programs, because I have said software is a set of programs, then what are these programs? Programs are a set of instructions, while a software are a set of programs. So we can say programs make a software, while set of instructions make a program, just as a basic definition of software. Maybe as well, I should be able to share these class notes so that we are on the same page. So I was saying software is a set of programs, while a program is set of instructions. Normally, software is in two categories: application software and system software. So I'll start from application software. Now, when I say application software, I mean a category of software that is designed to satisfy a particular need. It is a category of software designed to offer specific particular need to users. So I can just say that this is software designed for specific purpose. Examples of this software include MS Office. Yeah, you see, MS Office. Examples of MS Office, within the MS Office package, this is where we get Word, Excel, Access, PowerPoint, Publisher, those software which you normally use in your day-to-day activities. I think there's no one who has never used MS Office for purposes of word processing. When you want to type something like that, you're using MS Office. And we can agree that MS Office has been designed specifically for word processing. Another one is Excel. Excel has been designed exactly for purposes of mathematical computations. So you can see that when I say application software are software designed to achieve specific tasks. You see, so that you can easily realize from those examples that each of these software are doing their own independent specific tasks. Like WhatsApp. WhatsApp is also an application software, but it has been designed specifically for purposes of messaging or texting in that regard. YouTube is also another application software. It has been designed specifically to allow you to upload videos and watch multimedia videos. So other examples of application software, as you can see, include inventory management, student, Microsoft, PowerPoint, reservation softwares, and many others. You will need to understand that these application software are close to a user, easy to design, more interactive, and also slow in speed, easy to understand, manipulate, and always require very large the storage in terms of space. It consumes space. Now, when I say it is close to a user, what do I mean? I want to take you straight to a diagrammatic representation here, and then we agree with you that this is close to a user. You can see that diagram. This is the point where we have application software. You see, we have users. Immediately after users, we have applications. You see, this is the level where we have application software. Immediately after the users, or users in other terms, interact with application software. That is why we say application software is close to a user. Now, application software sits on top of operating system. Remember, in introducing this course, I said software is categorized into two: application software and system software. An example of system software is operating system. So you can see the system software is sitting on top of computer hardware. So when I say one characteristic of application software is actually is to allow users interact with the system, and users interact with the system considering their different applications that they use. So I hope if you get this diagram, the way it is, you can easily understand what we mean by application software and system software, the two categorization of softwares. So taking you back to where we are. So we have seen application software, some of these ones, and we can agree now with these features that they are close to a user, easy to design. You see, it is easy to design since you don't require any specialized skills as such. Because you remember, these ones are applications such as WhatsApp that you normally use. Others include Facebook. All those applications you know. So it is not difficult to design considering the way you can design a system software. Remember, the system software is sitting on top of computer hardware, which makes it again more complex. It is a more complex software since you need to keep in mind the computer hardware, and also you need to keep in mind the applications which are sitting on top of it. I hope you still have that diagram that we have agreed, that users sit on top, followed by application, followed by system software, and then the computer hardware. So you could see that application software are easy to design, since only you need to worry about the users most of the time, more interactive, and we can agree that these application software are very interactive, like WhatsApp. Yes, easy to understand. Do you need skills to use WhatsApp? You don't need any skills. There is also aspect about high-level language. We have said here that it is generally written using high-level languages. Just to make clear, when I say high-level languages, I mean languages which are close to human language. Remember, at the inception of this course, we agreed on generations of computers. The way computers evolved, also programming languages have been evolving similarly. So that we have also first generation languages, which are machine language. Second generation languages are assembly language. Third generation languages are high level languages. We have also fourth generation languages, like the one which I use for database. There is also fifth generation languages, which are used for purposes of artificial intelligence, AI, and expert systems. But my interest is on third generation, which is high-level language, which is the language which we normally use to write these application programs. So we can say that it is generally written in high-level language. I hope you understand the explanation. Now, having understood those ones, I would want to take you straight to system software. Now, you have understood application software. Now, system software. Please, before I proceed with system software, keep quiet, Brian. Once you enter the class, kindly mute yourself, or I remove you from my class. This aspect of joining class late and then coming when you are added to the class, you disturb the others. Even Anyika Tadayo, kindly mute. Yes. So I was talking about system software. And I want to revisit the diagram the last time. The diagram is you start from application software, followed by system software, application, that is users, applications, then followed by system software, and then computer hardware. So you should be able to having the chronology, the flow from users, applications, operating system, and then the computer hardware. And I said an example of system software is operating system. So system software is a collection of programs designed to operate, control, and extend the processing capabilities of computer itself. Now, these softwares are normally written in low-level languages, which interacts with the computer hardware. So I would want to agree with you this because it has come up again when I talk about the languages. In the inception, I don't know whether I can, let me check something here. Just I said in the inception, I said you start from first generation languages, you move to second generation languages, third, and then fourth. You see? So when I say, when I talk about the first generation languages, I mean machine language. You see? So when I talk about second generation languages, I mean assembly language. Then when I talk about third generation languages, I mean high level language. Then in fourth generation languages, I mean languages such as SQL. Then fifth generation languages, I say these are languages such as the language which is used in AI and machine learning, or in other terms, examples of these ones are Python. So when I say first and second generation languages, this is machine language and assembly language. Both of these are classified as low-level languages. They are low-level languages, a machine and assembly. But when I talk about high-level languages here, so I can write this one, high-level language. So these ones were machine dependent. And normally these high-level languages are in form of binary. Remember, I said at the introductory of this course that computers understand 1 and 0, which is actually the language of computers, or what we say, binary. So this is actually generally written in form of 1s and 0s. This is the language that computer understand. So when I say system software is written in low-level language, understand that it is actually a combination of 1 and 0. For example, if I want to write number 21 in binary, I would write like this: 21 equals to 1, 0, 1, 0, 1. This is actually in binary. So I hope you've understood when I say system software is generally written in low-level language. And I say that the low-level language is actually in form of 1s and 0s. And that is the language that computers normally understand. So I hope we are in agreement that system software is written in low-level language. Application software, on the other hand, is written using high-level languages. Now, features of this system software is that one, they are close to the system. Remember when I was talking about application softwares, I said application softwares are close to human or close to the users. But now this one is close to the system or the hardware. And you know, when I drew that diagram, I said we agreed that apps comes before, that is users, then followed by apps, then followed by system software, then followed by the hardware. I hope you still have this diagrammatic representation, starting from users, apps, system software, then computer hardware. So you can easily understand when I say they are close to the system. There is also aspect about difficult in designing, and this emanates from how it has been developed or programmed. Because the way you program system software is using combinations of ones and zeros, making it difficult to design and also difficult in understanding. It is not easy or easy to understand, as we said in application software. So other aspects include being less interactive, smaller in size, and then again, difficult to manipulate, generally written in low-level language, which we might have understood that clearly. So now this takes me to discuss in detail the system software, or what we say operating system. Now, an operating system acts as an interface between, I'm introducing operating system, which is an extension to software. I hope we are together so that we agree what is this thing known as OS. Operating system is a category of software acting as an interface, or is actually, let me admit this guy is joining late. So I have said OS is a software which acts as an interface. Interface is something which is in between. This operating system is an interface between the hardware and application programs. So it is in between the hardware and the application programs. Now, what are the functions of this application, the operating system? And remember, operating system is an example of system software. So one is memory management.